Let's talk about what a circle is both algebraically and geometrically. This definition is more in the spirit of geometry. It is geometrically a set of points that are a fixed distance from a point that you specify called the center. Now, if you're going to do it in a transition between geometry and algebra, then the center is going to get specified as a point in the coordinate plane, and a point in the coordinate plane has coordinates. So H and K are the standard letters to use for where the point is that's the center of the circle. And then the radius of the circle is going to be to connect the center of the circle with coordinates HK fixed with a point with coordinates that are to be allowed to vary, so variables x and y to identify the x coordinate and y coordinate of a point in the plane to make that the distance that's specified. The distance formula will do that. Let's look at an equation for the circle, and it's nothing but the distance formula. Remember, the distance formula had two versions. There was a square root version and a both sides squared version. This is the both sides squared version. The value of the distance between 2 points, we called it d in the distance formula. Here we're interpreting it as a radius, so r is the difference in x coordinates squared plus the difference in y coordinates squared. So instead of x1 minus x2 and y1 minus y2, we'll write it in this equation version as variables x and y, a fixed point specified the center of the circle with coordinates h and k, difference in x coordinates squared plus difference in y coordinates squared is r squared, is the distance formula just right for interpreting it as an equation of a circle. Now, algebraically, to use this formula, you're going to have to be able to manipulate an algebraic equation and interpret it as giving information about where the center is, the h and the k, and where the radius is. So here's an example. Suppose you want to graph an equation, x plus 1 squared plus y minus 3 squared equals 16. I don't want to do it by using a computer algebra system or a graphing calculator, so what I want to do is to graph it by hand. Let's make that happen. What do we know about it? Well, look at the equation as it's given, x plus 1 squared plus y minus 3 squared equals 16, and compare that to an equation with the distance formula version of the general equation for a circle. Notice that both the x and the y have minuses in that. So instead of writing it as x plus 1, it makes more sense to write x plus 1 as x minus a minus 1. Now I can compare x minus a minus 1 with x minus h, and y minus 3 as it was given with y minus k. And r squared with something squared, well, they were nice to give 16, so 16 is 4 squared, so r squared is 4 squared. Now do a pattern matching. Watch the numbers that show up here and match them with what shows up here, and where it was h, it's minus 1. Where it was k, it's 3. Where it was r, it's 4. So we can identify the three relevant parameters for a circle. H is minus 1, k is 3, and r is 4. So that's just right to graph this thing. Now let's plot some points. We want to plot a center at minus 1, 3, and we need radius of 4. Let's make that happen. Here's minus 1, that's 1 unit down, back, and 3 units up. 1 unit back and 3 units up to find the center of the circle at minus 1, 3, and the radius of 4. Now, radius of 4 means in any direction, but there are some especially nice directions that you might consider for the coordinate plane. Since everything is so neatly rectilinear, laid out in right angles, maybe a good way to get radius 4 would be to start where the center is and go 4 units east. 4 units east changes the x-coordinate from -1 to -1 plus 4 units, so 3, and leaves the y-coordinate alone. East or west, so there's -4 units. North, that's 4 units in the vertical direction, that's the y direction, so the y-coordinate changes from -1, 3 to -1, 7. There's 4, and here's -4. That's in the south direction. So from north, south, east, and west, you find 4 points that fit the conditions to be on the graph of the circle. They kind of anchor the circle. You know what a circle looks like, so draw the circle in through those 4 points centered at the given center of the circle, and that's what the graph looks like. Let's go from a general case to a special case. Let's look at a very special form of the equation of a circle. Let's make everything as nice as possible. Let's make h equals 0, so instead of x minus h quantity squared, it's x squared. And instead of y minus k squared, it's y squared. That puts the center at the origin where h is 0 and k is 0. And make r equal 1. Then x squared plus y squared is r squared. That's 1. And this is a particular circle. This is a circle with radius 1 and center 0, 0. That's the unit circle. Let's draw that by the recipe. Radius 1, so 1 unit east, west, north, and south. 1 unit south of the origin is -1. 1 unit west of the origin is 1. And the origin is the center of the circle. So it looks like that. I always think this picture looks like the crosshairs of a rifle. But if you don't think that, that's okay. It is a pretty abstract picture of a circle centered in a cross, and that is with the right labeling of the axes and the radius, the graph of the unit circle. Now, if you're given an equation, you probably won't be given the equation in that form of x minus h squared plus y minus k squared equals r squared. More likely is you'll have something neat and orderly in terms of an equation with a whole bunch of powers of x or y set equal to 0, and this could look like x squared, y squared, some constant times x for a middle term, some constant times y for a middle term involving y, and a constant term general c equal to 0. This is a nice compact form for an equation. It's called the general form, but it's not as crammed full of geometric information. To get the geometric information out, you need to recover the form of the circle that we called the standard form, where it looked like x minus h squared and y minus k squared, which makes it into something you can read off the geometric information. So what we need to do algebraically is take an equation like this and recover the information in the standard form. Algebraically, the way you do that is to complete the square. Now, you might remember that technique from an algebra course. You've got a quadratic, x squared, and 4x is a linear term, y squared and 8y as a linear term. Let's put the pieces together and make x squared and the 4x term, y squared, 8y, and make it so that the x squared and the 4x term have a constant term associated with them that will make a perfect square trinomial. So x squared minus 4x, and there's some magic constant that goes here. Y squared plus 8y, and there's a magic constant that goes here. and those things have to make the equation balance with as it was 5. Remember the trick for completing the square. You take a quadratic term, the linear term with a coefficient, the constant term that goes with this x squared and then this linear term minus 4x. To make a perfect square trinomial, you take half of the linear term coefficient and square it. So half of minus 4 is minus 2. Minus 2 squared is 4. So if you use x squared minus 4x plus 4, that will complete the square. That will make x squared minus 4x plus 4 a perfect square trinomial. Same thing, y squared plus 8y. Half of 8 is 4. 4 squared is 16. So the right constant term is 16. So I'm going to rewrite the equation and balance it with a constant of 4 going with the x squared term by completing the square, and a constant of 16 going with the y squared term by completing the square. The original constant on this side was 5. We add 4 to both sides. We add 16 to both sides, and it's still an equivalent equation to what we started with, but it has the advantage of factoring. X squared minus 4x plus 4 is x minus 2, that quantity squared. Y squared plus 8y plus 16 is y plus 4, that quantity squared. 5 plus 4 is 9, plus 16 is 25. So the constant term changed. We've got constants incorporated into each of these trinomials when they're expanded, so that I've got perfect square trinomials, and by doing that, that makes the form of this equation match the standard form for a circle. X minus h squared plus y minus k squared equals r squared. X minus h is x minus 2, so h is 2. Y minus k is y minus a minus 4, is y plus 4. Y minus a minus 4 makes k equal minus 4. R squared is 25, so r is 5. That's all the information that we need to graph the circle. It has center, it has radius. Plot the center, step north, south, east, west from that center point 5 units, and those are points on the circle. Now you should be able to graph the center and out those distances to get what the radius of the circle is, what the whole graph of the circle is. So there's some homework problems to try these. What you really need is to drill on this completing the square technique. If you're not comfortable with it, or it's a little old or a little strange, make sure that makes sense so that you'll be able to handle the problems. That's the main algebraic tool for all of these. So give some of them a try and see what luck you have.